Lesson 12, Configuring Data Protection Mode. In this lesson, we will discuss about 3 possible data protection mode in the data guard environment. And we're going to discuss how to change data protection mode based on our requirement. We can use Enterprise Manager Cloud Control to adjust the data protection mode level. And we can also use Data Guard Broker command line interface. And we can also use a SQL statement as well. Data protection mode requires a specific redo transfer mode, either synchronous redo transfer mode or asynchronous redo transfer mode. However, this redo transfer mode alone does not define data protection mode. When condition is met, under the data protection mode, specific actions are taken so that hold together redo transfer service and conditions and also result of a certain condition all together define data protection mode. There are 3 data protection modes available. One is a maximum protection, and the other one is a maximum availability, and the other one is a maximum performance. Maximum protection, its main goal is achieving 0 data loss. So we always have to keep synchronous standby database that is synchronized with the primary database all the time. If it's not possible to keep synchronized data guard environment, then internally one action is taken. And also maximum availability. Now in this case, availability of a primary database is its main goal. So initially this protection mode, it tried to maintain synchronous standby database in the data guard environment, but if it's not possible, then flexibly we can keep unsynchronized standby database in the data guard environment. And also, it always provide service through the primary database in case of in case it's not possible to keep synchronized standby database. So this data protection mode, it is to provide continuous service to the primary database. And maximum performance is maintaining good performance of a primary database transaction is its main goal. So depending on your environment, you can choose appropriate data protection mode. There is no single best data protection mode. It's all depending on what is your requirement and also what do you want to achieve. It's all based on that. So from this page, we are going to discuss about maximum protection mode and maximum availability and also maximum performance. Since next 3 slides are all text-based, I better show you whiteboard example so that way you can easily understand differences between maximum protection mode, maximum availability, and maximum performance. So I'm going to jump into whiteboard. Okay, so I'm in the whiteboard. So let me actually explain one at a time. So let's go with maximum protection. So maximum protection is, it doesn't require synchronous redo transport service. So if you have a very simple configuration of a data guard, then you will have here primary database, and also you will have a standby database. Let's say your primary database is a Boston database, and your standby database is a London database. And also Boston database, we have an online redo log file, and in the standby database we have a standby redo log file. So here online redo log, and the other side we have standby redo log. The Boston database, it transport redo to London database synchronously. So synchronous redo shipping is a requirement. If you recall, we discussed about synchronous redo shipping. So during the normal time period, you can make transactions. So you can connect to primary database, and you can make insert, update, delete transactions. And these transactions generate redo, and then redo is written to online redo log file. Suppose that you issued a commit statement at system change number, SCN number 1000. At system change number 1000, we committed a transaction. Then redo for committed transaction must be written to online redo log file. But this transaction commit statement is not complete yet under synchronous redo transfer mode. Under synchronous redo transfer mode, we have to wait until redo for the committed transaction is delivered to London database in the physical standby database, and also redo received in the standby database, it must be written to standby redo log file, and then commit can be complete. So London send the message back about successful redo delivery, and the commit can be complete. So it takes time, but it guarantees zero data loss. So synchronous redo shipping is sending redo to the London database synchronously with respect to commitment. And also there is one more requirement, a form. A form means redo delivered must be written to standby log file synchronously. So that is a synchronous disk I/O. That's a requirement. So in this the scenario, let's make one example. One example is if there is any problem with network here. So you have a network issue. If that is the case, when you attempt to commit at next system change number, let's say 1001, at this time, the redo for committed transaction is written to online redo log file in the primary database, and also primary database try to transfer redo to standby database, but because of a network outage, it's not possible to deliver the redo. In this case, Boston database wait up to network timeout, net timeout, by default 30 seconds. If a London database doesn't respond, then here's the action. Your primary database shuts down. Wait a minute. Primary database shuts down. That means it will affect your production environment. Yes, that's what it is. What was the main goal? Our main goal is achieving zero data loss. Think about that. You had a network issue. Okay, if a network comes back, then if you have a network issue, and then you're gonna make another scenario. Let's say you have a primary database issue as well at the same time. So you had a network issue for 2 minutes, and a network issue for a short amount of time, and also you have a primary database issue. In this case, you may want to use the London database, and then you can just bring up as a primary. Now, in this case, you're not going to lose any data, okay, in terms of committed transactions, because your London database is always synchronized with the primary database, even though you have a network issue, and right after you have a site issue, primary site issue. You can fail over to London database in the worst case, and then you can provide a service to your application directly from London, because your London database is synchronized with the Boston database. Because the time when you issue the commit statement, the commit wasn't complete because the redo wasn't delivered to London database successfully because of a network failure. So what that means is your transaction committed in the Boston database up through system change number 1000, your London was synchronized based on system change number 1000. So synchronized. Okay? So even though you have a double failures, you have a network failure, at the same time you have a site failure, that's fine. In the worst case, we can use failover to London database. We keep same synchronized data. There is no microsecond loss of data because we configured data guard for this purpose. So it can protect your data from double failures. However, practically, this is not really good. Why? Because your primary database is down even though we have a network issue. So let's say we have a single failure. Even though you have a temporary network issue, why we have to shut down primary database? Or another single failure. We have a standby database problem. Why do I have to bring down Boston database? So this may be actually your challenge. Even though you can achieve zero data loss from double failures and also single failure, but it affects your primary database transaction. That's why when you configure maximum protection, it is a common best practice to have local standby database, like a Chicago. So just have a local standby database. So you have another online redo log file. So Boston database, it transport redo to London database and also redo to local standby database. So same scenario. If you have network issue, it will not shut down Boston database. Why? Because I still have a valid connection to a local standby database. What if you have a problem with this network? That's fine. I still have at least one synchronous standby database. What if you have this standby database crash? That's fine. At least I keep one synchronous standby database. So in the maximum protection, as long as you keep one synchronous standby database, then we can keep primary database up and running, because we can keep the synchronized standby database. We can also achieve zero data loss in case of double failures. So that is maximum protection mode. So what I'm going to do, I'm going to come back to a slide to compare with the actual information in the text and also this discussion. Okay, so here, maximum protection mode. First bullet, maximum protection mode ensures zero data loss in the event of a failure of the primary database and network or all standby databases. That's what we saw. The primary database shuts down if a fault prevents it from writing its reader stream to enlist one synchronized standby database. So as long as you have one synchronized standby database, then it will not happen in this way. So it's a good idea to have more than one physical standby database. And redo data must be written to both the local online reader log and the remote standby reader log on at least one synchronized standby database. Makes sense? That's what we discussed. And configuration requirement, at least one standby database must have standby reader log, and the standby database destination must be configured with a sync and affirm redo transport attribute. So that's a requirement. So maximum protection mode is the highest protection level, and it doesn't require synchronous and affirm redo transport service. And then if it's not possible to maintain synchronized standby database, your primary database shuts down. That's what we discussed here. Now, next protection mode is the maximum availability. So I'm going to show you whiteboard example, and I will come back to discuss further. Okay, so let's talk about maximum availability. This time here, we have a maximum availability. So in this data protection mode, availability of primary database is a key configuration goal. So just like the previous example, we have a primary database, and we also have a standby database. And require the reader transport service is a synchronous reader transport service. So Boston database transport redo to London database synchronously. Up to this point, it's the same as maximum protection. But condition and result of a condition is different. So let's say we actually configure synchronous reader transport service. So everything is fine. So from primary database, I commit at system change number 1000. Then redo for committed transaction must be delivered to London database synchronously. And then Boston database, it must receive successful redo delivery, and also that delivery must be written to standby redo local file, and then we can commit a complete commit statement. And also, when you commit at 101, then we can also transport redo for committed transaction at system change number 101. So that's always synchronous in this way. And then we can commit transaction in the primary database. Now, let's make a single failure here. We have a network failure at this time. If there is a network issue, then Oracle will keep your data guard environment unsynchronized mode. Until network is recovered, your standby database is unsynchronized. So it's more flexible. Why? Because keeping primary database up and running, that's more important in your environment. So whenever possible, achieve synchronous redo transport service to achieve zero data loss. However, if it's not possible to keep synchronized the standby database, then just give up synchronous redo shipping just for temporary until network is recovered. So we have an unsynchronized mode just for temporary. So primary database, soon as the redo for committed transaction is written to online redo log file, then we can complete commit statement. So this redo for committed transaction at 1002, 1003, this is not available in the London database. And later on, if a network is recovers, then we can actually transport missing redo to standby database. It's by archiver or MRP process can request missing redo to resolve missing redo. So that that is the idea. But what about this case? I have a network crash again. So we have a network outage. And at this time, we have another transaction continuously issued in the primary database. So we have 1004, and also we have 1005. So we committed the transaction at this time. That's new transactions. So my London database is a little behind now. At this time, we're gonna actually make scenario second failure. So your first failure is network outage. So second failure is your primary database failure. So that is second failure. So that's a second failure. So we have a second failure here. And you also have a first failure, which is network outage. So what if you have a network issue and you have a site issue at the same time? Then your choice could be failing over to London database. Okay? So in the worst case, in this case, so did you lose data in this circumstance? Absolutely. We lost these committed data. Okay? Because we have a network outage, thus we couldn't transport redo to standby database. So we kept London database unsynchronized. And just a few minutes later, we have a site failure. But we committed some more transactions in the primary database, but it wasn't delivered to standby database. In that case, you have a loss of data. So with the maximum availability, it protects your data from first failure. But you will have minimal loss of data in case of double failures. With the maximum protection, even with the double failures, we always keep synchronized the data because that was the goal. If it's not possible to synchronize standby, we had to shut down primary database. However, with the maximum availability of a primary database is more important. So even though the case where the standby database cannot be synchronized, we still keep your primary database up and running unsynchronized mode. So that is another case. So let's come back to slide. So quick review. Maximum availability mode, it ensures zero data loss without compromising the availability of the primary database. Redo data must be written to both the local and also online redo log and received by remote RFS process of a physical or logical standby database. The primary database does not shut down if it cannot receive acknowledgement from at least one standby. If no synchronized standby databases are available, the primary database operates in an unsynchronized mode until at least one standby database is synchronized. Configuration requirement: at least one standby database must have a standby reader log, and the standby database destination must be configured with synchronous NOAA. That's a minimum level. So it's a one lower level compared to maximum protection. Maximum protection required sync of fun. However, in this case, soon as a redo can be delivered to standby database synchronously without waiting for a disk I/O to standby redo log file, we can actually complete a commit statement in the data guard environment. So we have a synchronous network I/O, but asynchronous disk I/O, but that's a minimum. Okay, so that is actually a maximum availability mode. Now let's talk about maximum performance. So I'm going to show you whiteboard again. Okay, this time I'm going to leverage the copy of whiteboard work. So maximum performance. And we don't need this. We don't need this. Okay, so with the maximum performance, the required redo shipping is asynchronous redo transfer service. So just during the normal time, your redo is continuously transported to standby database. You do insert, update, delete. Redo for DML always transported to standby database asynchronously, even with synchronous redo transfer service. Remember that synchronous, asynchronous, it's based on with respect to commitment. At the time when you commit, do you want to transfer redo for committed transactions synchronously, asynchronously? That's the meaning of a synchronous redo transfer mode and also asynchronous redo transfer mode. So idea is, soon as the primary database commit transaction and that is written to online redo log file in the primary database, your transaction is complete without having to wait for the redo delivery for the committed transaction to standby database. So the benefit of maximum performance is, since we can complete commit statement continuously without having to wait for acknowledgement from the standby database, we can maintain very good performance of a primary database. But downside is, if you make a single failure, for example, I just have a primary database site issue. For that moment, your standby database was just slightly behind. Then, when failing over to London database, you will have a loss of data. Luckily, your London database was just synchronized with the primary database. Then you don't lose any data. So, it doesn't guarantee zero data loss in case of a single failure. So that's a maximum performance. Its main goal is to maintain good performance of primary database transactions. So let's go back to slide. Okay, so we have a maximum performance. It is a default level of a data protection. And this mode provides the highest possible level of a data protection without affecting the performance of the primary database. Transactions can commit as soon as the redo data is written to local online redo log. Redo data is shipped to the standby database asynchronously with respect to commitment of the transactions that create the redo data. Configuration requirement, standby redo logs on at least one standby database, at least one standby database that is configured with the async and no affirm redo transfer mode. That's what we learned. Summary. Maximum protection. Risk of data loss. Zero data loss, double failure. So we can achieve zero data loss from double failure and install primary until an acknowledgement is received. But if it's not possible to keep synchronized standby database over net timeout, then your primary database will down. And maximum availability, zero data loss with a single site failure. Sync and affirm, it can be configured, or you can lower. You can actually set this in a redo transfer mode lower. So sync and no affirm. Potential for data loss when multiple site failures, because it is a no affirm. And maximum performance, its main goal is to maintaining good performance of a primary database transactions. So because of async redo shipping, in case of a single or double failure, you have a potential loss of data, even though that is minimal. Now we're going to take a look at Enterprise Manager, how to set data protection mode. In the database page, primary database page, we have a maximum performance data protection mode. When you click this link, it will move into the next page. So we have a maximum protection and maximum availability and maximum performance. Actually, this screenshot is not coming from previous screenshot. If your data protection mode is a maximum performance and redo transfer mode is asynchronous redo transfer mode, then you will have only maximum availability and maximum performance. Two options. However, if your redo transfer mode is a synchronous redo transfer mode, then one more option is available, maximum protection. So you will see maximum protection, maximum availability, and maximum performance. These are the three possible cases. And you can also set data protection mode by using DataGuard broker command line interface. So in this case, depending on your data protection mode, you have to set redo transfer mode that is required, either sync or fast sync and async. So after changing redo transfer mode, and you can promote it to maximum availability or maximum protection. And you can also perform same task using SQL Plus. At the SQL Plus prompt, you can issue statement alter database set standby database to maximize availability. Select protection mode from $V database. So it will give you protection mode information. Quiz. Which of the following are allowed DataGuard protection mode? We discussed about maximum protection. We discussed about maximum availability. We discussed about maximum performance, but we haven't discussed about maximum throughput. So the answer is A and B and D. This is lesson 12. Practice 12-1, examining the maximum availability protection mode. In this practice activity, you will use data guard broker command line interface to view the current protection mode, and you modify it to maximum availability. The first step is you open up terminal window on host 01, or you can use existing terminal window on host 01, and you set environment variable correctly and get into data guard broker command line interface, connect to Boston database as a sysdg. And let's check current configuration of your data guard broker. The status is good, success, and Boston is the current primary database, Boston FireSync, and London 2. Current data guard protection mode is a maximum performance. Now we're gonna check read transfer service mode by using log export mode property. So my FireSync, Boston FireSync, is a read transfer mode is asynchronous, and also London database is also asynchronous. In order to promote your data protection mode from maximum performance to maximum availability, the minimum must be fast sync or synchronous read transfer service. Optionally, if your current the read transfer mode is synchronous instead of asynchronous, for this practice activity, make sure you adjust log transfer mode to asynchronous. This is to practice maximum availability, to see how it works with the asynchronous read transfer service. And then we're going to exit out data guard broker command line interface, and we're going to use SQL Plus to get into Boston database. And let's take a look at log archive dest2. The log archive dest2, it includes all configuration that defines remote log archive destination, including the attribute of any parameter. According to this is a synchronous read transfer service, meaning that Boston database transport redo to Boston FireSync synchronously. So Boston FireSync is async, and this is a synchronous. So that's different. So remember that. And I will exit out, and I will connect to Boston database again. Now this time we're gonna check another property, show database Boston redo route. Now as you can see, Boston database transport redo to Boston FireSync synchronously if current database, the primary database is Boston. So we have two different observations with redo transport. The redo transport mode, it's asynchronous redo transport, and with the redo route, it's synchronous. So which one is a higher priority? If you have a log transfer mode and redo route, the attribute setting, the redo route takes higher priority. So Oracle Data Guard will take synchronous redo transfer service. So for testing purpose, we're going to edit redo route to use asynchronous redo transfer service. So the meaning of this, the property is, if a Boston database is a current primary database, the Boston transport redo to Boston file sync asynchronously. It was synchronous. Now we are changing this property to asynchronous. And then we're going to change it data protection mode from maximum performance to maximum availability. As you can see, it's not allowed because the minimum, the transport mode is either fast sync or synchronous read transport service to be able to use maximum availability. So we're gonna actually change it to fast sync because that is a minimum required read transport mode setting. And after you change it to fast sync, then you should be able to set data protection mode to maximum availability. So as you can see, with the asynchronous redo shipping, it wasn't possible to set data protection mode to maximum availability. However, when you change it to a fast sync, then it's possible to edit your data protection mode to maximum availability. So now let's display the result of the configuration status. When you run show configuration, now you have a change in the data protection mode, which is maximum availability. Now we're going to get into host shadow 4, host shadow 3, and we're going to simulate one thing. And I will shut down abort. So my physical standby database is down, and I'm going to check the status of data guard broker configuration. As you can see, we got the message. The error says redo transport error for one or more members. Because your London 2 is down, the Boston file sync cannot transport redo to London database. So that's the message of what we have. And then we're going to start up London database up to mount state. And then we're going to check the status of a pluggable databases. Okay, it's a mount state because your instance is a mount state. So now I will come back to here and show configuration. Okay, so according to this, London physical standby database is not available even though we restarted. So it takes a little bit of a time to catch up the new database status. So we will have to wait a few seconds here. So I'm going to run it again. Okay, so still I have the same message here. So go back here. My standby database is mount state, but the data guard broker process didn't catch up the new status. That's why it's still showing the status of London as it's not available. So now, as you can see, everything came back to normal. So next step number 16, it's actually an optional task. Sometimes you check the status before London database start MRP background process. So let's double check here. Redo apply service pgrep -lf MRP. So as you can see, MRP process automatically started. So if you see the success as a final result, you don't really need to start redo apply service manually because it came back to normal. But before starting MRP process from Boston side, the London side, you can actually the start MRP to start MRP process immediately without waiting. And then you can switch log file. So that way you can see the normal status, the faster. So that's what you can do. So let's check transport log lag and also apply lag. So everything came back to normal. So there's no lagging for the transport and also apply. So in this practice activity, we changed reader transport service mode using the log export mode property and also using reader route property. And in order to set data protection mode to maximum availability, we had to set reader transport mode minimum fast sync. And then we simulated standby database failure. So we shut down a board, and then we monitored the status of data guard broker configuration. So there was a lot of error messages and warning messages. And then when you restarted Boston database, data guard broker was able to collect all new status of members of a configuration. So finally, we got the normal status. And this is a practice 12-1. Practice 12-2, examining the maximum protection mode. And this time, we're going to perform same tasks like a practice 12-1, but with a different data protection mode. So with the maximum protection mode, if physical standby database goes down, then what will happen in the primary database? So we will perform same tasks, then you will see different observation and different result. That's what you're going to see from practice 12-2. In order to promote your data protection mode to maximum protection, redo shipping must be synchronous redo transport service. So you will change a property of a Boston database to transport redo to Boston far sync synchronously. So I'm doing it in the data guard broker command line interface session. I didn't exit out in the previous practice activity, so I use the same session. And then I will also edit configuration to set data protection mode to maximum protection. So this is not allowed. The reason why it's not allowed is because data protection, it doesn't allow to add far sync in the configuration. So in the redo transport path, we will have to get rid of a far sync. So what we're going to do, we're going to edit far sync, Boston far sync, to transport redo to London 2. So what that means is your Boston database, which is a primary database, transport redo to the London database directly. So that's what we're going to configure. So in this example, you have Boston far sync. If a Boston database is a primary database, it transport redo to logical standby database, not to physical standby database. And then we're going to change the reader route for Boston again for the different reader transport path. So in this case, if a Boston database is a primary database, Boston transport redo to London directly. Okay, so that's in our new reader transport service path. So Boston transport redo to London directly. So there is no far sync in between. So the purpose is, it is to set data protection mode to maximum protection. So now it's possible. So when you look at configuration, so Boston database, it transport redo to Boston far sync and to London. However, Boston far sync doesn't transport redo to London, Boston transfer redo to London directly. So that way we could set data protection mode to maximum protection. So I'm going to exit out. Now we'll log in as sysdba. And now we'll get into dep1 pluggable database in the primary database. And then I will open up host 03. And I already got into SQL Plus to connect to London database. And I will simulate London database failure just like practice 12-1. Shutdown abort. So remember that your data protection mode is a maximum protection. And you have a failure in the standby database. So there is no way to keep synchronization between primary database and standby database. So we're going to return back to Boston database session. And then we're going to query So I'm able to display the output, but when you attempt to insert, then what will happen? Okay, I can insert. However, when you commit, you will get error message. Why? Because in order to keep synchronous physical standby database, we have to have a physical standby database up and running. So that way, this insert statement and commit works, and the reader for committed transaction must be transported to standby database. However, my standby database is not running, so it will affect your primary database. So this will be down eventually. So if it's not possible to keep synchronous primary standby database at any given point, then your primary database shuts down. And that's the maximum protection mode. So it's going to take a little bit of time. So I added a note here. It takes about 1 or 2 minutes to receive a connection related error message. Okay, so I'm going to pause the recording for a few seconds and I will come back. Okay, so after waiting 1 minute 30 seconds, I got this message. So when you do practice activity, you will also have to wait for some amount of time. So, my London database was down. That caused my primary database down because it's a maximum protection mode. So I'm going to exit out. And the same terminal window. And let's try this now. So my primary database was down. What if you attempt to restart? Does it work? So your London database, which is a physical standby database, still down. Then what will happen when you start primary database at this point? So after waiting, for a few seconds, you will notice that you will have the same connection problem, the end of channel communication problem. So meaning that it's not possible to start up your primary database because your London database is down. So there is no way to synchronize your primary and standby database because that's the most important part with the maximum protection. So now what we're going to do, I will come back to London database and I will start up mount. And let me check pluggable databases. So dep1 is a mount state, which is good. I will come back to primary database and I will start up. This time it should work because your London is fine. So we can transfer redo and apply redo synchronously. The current status is mount to state. It takes a little bit of time, so just wait a couple more seconds. Okay, finally my database is open. My pluggable database is open with the write mode. So now we're gonna use data guard broker command line interface to check the status. Okay, so I got this message. So member disconnected from redo source for longer than specified threshold. Because your standby database was just shut down for a couple of minutes, and also your primary database was down for a couple of minutes. So that's why we got this message. So in order to clear this warning message, we will have to wait 1 or 2 minutes. So I'm gonna pause this recording and I will come back to double check. So I waited for about 30 seconds. I will double check. So finally it came back to normal. Okay, since we completed the testing, we're gonna switch back to maximum performance. And then we're going to also change the reader transfer service back to original state. So Boston database will transfer redo to Boston FileSync because we lower the data protection mode from maximum protection to maximum performance. And also Boston FileSync transfer redo to London and London 2. That's the original state. And then we're going to start redo apply service. And switch log file, and let's check the status of a data guard broker configuration. So now it's data protection mode is a maximum performance, and the redo shipping is back to original state, so everything is good. And make sure there is no transport lag and apply lag. So I will copy, show database London. Okay. So there is no transport lag and apply lag, everything is good. So for future practice activities, I will exit out of a data guard broker command line interface and also from SQL+. So everything is good. This is a practice 12-2.